This question is asking us to write an equation of a line that is the perpendicular bisector of segment AB with A at -9, 1 and B at 1, -3. I'm going to start by graphing these 2 points. It's easier for me to think about this visually if I can see it on the graph. So I graphed these points, A at -9, 1, B at 1, -3. So now looking at this segment, in order to determine the bisector, I need to find the midpoint of this segment, meaning the point in the very center between A and B, still along this line segment. So I'm going to do that by drawing in the total rise over run. So I'm basically looking at the vertical and horizontal distance that it takes to get from point A to point B. And I'm going to count what those distances are. So the vertical distance is 1, 2, 3, 4. The horizontal distance is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And to find the midpoint, I'm going to think about half of this distance. So I know that half of 4 is 2. So I'm going to go down 2. Half of 10 is 5. And I'm going to go over 5. So this point right here should be the midpoint. To check and make sure I did that correctly, I can continue with down 2, right 5 again, and I should perfectly end up on the other endpoint, which I do. Okay, so here's my midpoint, and these coordinates are, let's see, 1, 2, 3, 4, and down 1. So the coordinates of the midpoint are -4, -1. Okay, so that's the first thing that I needed to figure out. Just going to make a note of that here. The midpoint is at -4, -1. Okay, I also, for a perpendicular bisector, I need to figure out the slope of this segment, which I kind of already did because I was using the rise over the run to think about the distance from A to B. So the simplified rise over run would be down 2, right 5. Looking at this segment, reading it from left to right, it's going down, which means it's going to be a negative slope. So I also have the slope of segment AB is -2/5 or -2/5. I'm looking for a perpendicular line, which means that my new slope, the slope of the perpendicular bisector, will be the opposite reciprocal of the original slope. Opposite meaning I'm changing the sign, reciprocal meaning to switch the numerator and denominator. So this will be a positive slope. 5 will now be in the numerator and 2 will be in the denominator. So from here, there are a couple ways I can go. I can go back to my graph, or I can just write this in point slope form. So I'm going to do both. So let's start with point slope form. So I have a point that will be on the perpendicular bisector. It's going to go through the midpoint, and I have the slope. So perpendicular or point slope form, the general formula there is y minus y1 equals m times x minus x1. M is 5/2. X1 and y1 come from the point that we know is going to be on this line. So y minus y1, y1 is -1, so minus a -1 will become y plus 1. M, the slope, is 5/2. X minus x1, so that's minus a -4, which will become x plus 4. Okay, if I wanted to think about this instead graphically, I could use, bring my graph back, I could use slope-intercept form. So for slope-intercept form, which is y equals mx plus b, I need the slope, which I have, but I also need the y-intercept. I don't have the y-intercept yet, so let's think about that. So let's start from our midpoint, and I'm going to follow the new slope, which we said was positive 5 over 2. So that means I'm going to count up 5. So 1, 2, 3, 4, 5, right 2. So this point will also be on the line. So I could graph the line approximately now, but because I want to figure out the exact y-intercept, I'm going to count that same slope again until I actually hit the y-axis. So now I can see this is B, this is my y-intercept, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. I can graph the whole line if I want to see what it looks like. And I can write my equation in y equals mx plus b slope-intercept form. So in that form, this is another correct way to write this equation. Y equals m is 5/2, that's my new slope. Don't forget x here. And b, the y-intercept, is plus 9. So even though these two equations look a little bit different, they're in different forms, they are actually representing the same line. And if I went through and distributed the 5/2 here and moved the 1 over, I would see that they are exactly the same.